Okay, this is Techmath1. We will be looking at Chapter 1, Real Numbers. So let's take a look. This is out of the blue book. And we're first going to look at 1, 2, 3, 4, 5, and 7. So number 1. Let's see. Instead of writing plus 9 for positive 9, we usually just write 9. That's part A. Part B, would it make sense to write either plus 0 or negative 0? No. 0 has no sign. So 0 is just 0 no matter what. Even if you had the negative 1 times 0, it's still going to be 0. All right. 2. So this is in the blue book on page 2 on real numbers. We're on number 2. There are various subsets of real numbers. Natural numbers are 1, 2, 3, 4, also known as the counting numbers. The set of whole numbers are the counting numbers with 0 included. Which number is a whole number but not a natural number? That would be 0. 0 is a whole number, but counting numbers or natural numbers start with 1. Roman numerals were actually natural numbers. They don't have a Roman numeral that signifies 0. And no fractions either. All right, so number 3, another subset of real numbers is the set of integers, which shows below. Integers are whole numbers with positive or negative on them, all right? So is 4 both a whole number and an integer? Yes. 3B. Is 0 both a whole number and an integer? Yes, 0 is. And C, is negative 5 both a whole number and an integer? No. Negative numbers are integers. Whole numbers are just 0, 1, 2, 3, 4, 5, and so on. All right, number 4. We've got, what do we have for number 4? Any subset of real numbers is rational numbers, rational or fractional, right? Fractions. So let's see, negative 13 ninths can be written as, you could either have it negative, so here's how they have it right now. The negative right there. We could say negative 13 over 9, or we could say 13 over negative 9. This, and this all mean exactly the same. It really doesn't matter where you put the negative on a fraction. Number 5, they already have it divided out for us, so we don't have to divide it out, but they have 4 elevenths, and so they said round to thousandths place. So they did the long division for us in the book. They got 0.3638. So we have tenths, hundredths, thousandths. So to round to thousandths place, you look at that number and then you look to the one to the right of it, 10 thousandths place. If it is 5, 6, 7, 8, or 9, we bump it up. If it's 1, 2, 0, 1, 2, 3, or 4, we just truncate it off and leave it a 3. So because that's an 8, that gets bumped up to a 4. So 0.364 is rounded to thousandths place. Let's look at number 7. Any decimal is a rational number because it can be converted to a fraction. So look, 13.7, we can look at that as 13 and 7 tenths. If you read it out loud, we usually say 13.7, but really this is 13 and 7 tenths. Whatever place it is, this was like 364 thousandths. So you say the number and then you say tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, depending on what the last place is on the decimal. All right. So 4.19 is actually read 4 and 19 hundredths. So put the 4 down, you write the 19 down as a whole number. There's another way to do it. You can use the algorithm where however many places you put a 1, and then however many places, that's how many zeros you put down. So that's read 4 and 19 hundredths. This is read 13 and 7 tenths. So look, I put the 7 down. How many places to get it to be a whole number? Just 1 0 there. So that's another way of thinking of it. So 0.854. That is 854 thousandths, or 854 over 1, and then 1, 2, 3 places. So 1, 2, 3 zeros. All right. Let's look at page 4. Number 9 and 10 and 11. We're going to do those for notes. So normally I don't do quite this many. These are just really quick problems. So number 9 on page 4 is write 140 as a fraction and write negative 79 as a fraction. So that's 140 over 1. It's negative 79 over 1. All right, number 10, state whether each number is rational or irrational. So irrational numbers are non-terminating, non-repeating decimals. Rational numbers can be expressed as four two. So there's a difference between infinite numbers and irrational numbers. Irrational numbers are non-terminating, non-repeating decimals, meaning you can't find a repeatable pattern. Rational numbers have some kind of pattern to it or just stop. So this one just stops. That one's rational. This one has a pattern to it. 4, 2, 4, 2, 4, 2. So I would know this is 4, 2, and then 4, 2, and then 4, 2. So that is rational. And then I think the last one, C, is irrational. It's 4.030030003. It does have a thing to it, but it's irrational. It's not a repeated pattern over and over again. So we could figure out what's next, but that's an irrational number. That's a special kind of number. I'm surprised they threw that in there. All right, so 11. Let's look at 11. We got, say whether each number is rational or irrational. And so now they want you to use your calculator, the square root of, what do we got? The square root of 3, the square root of 16, the square root of 49, and the square root of 89. So this one's irrational. That's a non-terminating, non-repeating decimal. If you do the square root of 3. Square root of 16, that's just 4. So that's rational. You can write that as a fraction, 4 over 1. 7, that's rational. You can write that as 7 over 1. So if it can be expressed as a fraction, the division of two numbers, it's rational. If it's a non-terminating, non-repeating decimal, you can't write it as the division of two numbers because we don't know what the pattern is. All right, and the square root of 89, that's irrational. Non-terminating, non-repeating. All right. Let's look at 1, 2, apps order and absolute value. So jump to number 13. So this is 1.2 in the blue book. So we're looking at, just comparing. So 6 compared to 9, and 10 compared to 4, and 1 compared to 5. This is number 13, 1.2. And then 14, let's see, 14, a bunch more comparisons here. 7 compared to negative 4. Oh, here, you know what, I'm going to take that. I want you to think they're equals 2 signs. What else? We got negative 3 or negative 5. Geez. Negative 5 and 0. 7, negative 6 and negative 2, and negative 4.5 and negative 9.5. And then here we'll keep going. Number 16 is the absolute value. 10, the absolute value of 3/5. The absolute value of negative 1. The absolute value of negative 9.7. The absolute value of negative 12. The absolute value of 12. The absolute value of 0. And the absolute value of negative 45. Okay, so let's take a look at those. We've got comparatively, whichever one is farther to the left of the number line, the inequality sign will always point at it. So look, 6 is farther to the left of the number line than 9. So 6 is less than 9. 10 is greater than 4. See, 4 is farther to the left of the number line. It's pointing at the 4. 6 is farther to the left of the number line. It's pointing at the 6. 1 is less than 5. So that's no big revelations there. Gets a little tougher when we look at negatives, because now this is farther to the left on the number line than that. This, it's negative 5 is less than 0. It's farther to the left on the number line. Farther to the left on the number line. Farther to the left on the number line. That's probably the toughest one. When you have a negative compared to a negative. Then your brain is seeing 2 and 6, and it's thinking 2 is less, but it's negative 6, so that's farther to the left on the number line. This is actually smaller than that. You'd rather owe somebody $2 than owe somebody $6. Negatives are like owing, okay? Absolute value is just how far from 0. So how far is positive 10 from 0 on the number line? Well, that would be 10 clicks away. 3/5, that would be 1, that would be 9.7. How far is negative 12 from 0 on the number line? That would be 12, 12, you know, that's the same distance. Positive and negative 12 are the same distance in different directions from 0 on the number line. The absolute value of 0 is 0. That is the only absolute value that isn't positive. All the rest of them are positive. So sometimes students are like, oh, you guys are always just trying to make everything confusing. You say, when I take the absolute value, it's got to be non-negative. Well, think about what non-negative means. That's 0 or positive. So it's a one-word description that so you don't have to say or. All right, so negative 45, the absolute value, that's 45 clicks away from 0 on the number line. All right. Let's take a look at 1.3. So 1.3, we're looking at number 19. And so that is negative 40 plus 10 and 80 plus negative 55 and negative 20 plus negative 70 and negative 30 plus 90. And then I also wanted to look at 22. That is negative 1/2 plus negative 1/5. We'll leave some room. And negative 1/6 plus 1/10. Okay, so these, adding positives and negatives together, you think of it as a tug of war. Look, if I had this on a number line, and negative 40, here's 0. There's a force being applied at this point of negative 40. And then there's also a force being applied at that point at positive 10. Well, who's going to win that tug of war? Well, the negative is going to win. By how much? A negative 40 versus a positive 10, it's going to win by 30, and it's going to stay negative. The reason that those are hard to get your head around is because these are abstract concepts, meaning that there isn't such thing as like a negative $1 bill and a positive $1 bill, and you put them together and they disappear. I guess in chemistry, you think of acids and bases, parts of acid, parts of base. that when you mix them together, you get just water. They kind of wipe each other out. But that's probably the closest real life thing that we have. We use this, right, with debt, with, like I said, in physics, we use it as forces applied at an object. But other than that, there isn't, you know. And again, you have a calculator at your disposal for every test, so you shouldn't get any of these wrong ever. So what is that? That would be 25 positive, right? Because it's like you have $80, you spend 55, you're left with 25. These are both negative, so that isn't a tug of war. That's pushing it 20 to the left, and that's pushing it another 70, so negative 90. Or if you think about debt, I owe him 20 bucks, I owe him 70 bucks. I owe 90 bucks. I don't get to subtract it and go, well, since I owe you 70 and you 20, I only owe 50. That's not how that works. All right, negative 30 plus 90, that's 60. These are tougher. Fractions, in order to combine fractions, you have to find a common denominator. And that's like, think about pizza. If I buy a personal pan pizza and you get this little tiny slice, right? Little baby slice. So I eat 3/4 of it, but there's one tiny little slice left. And I come home and I find out my son and his friends got a large Pizza Hut pizza. And there were 3 slices left of that. Well, it wouldn't be right for me to say, okay, there's 4 slices of pizza left, because I got this one little baby piece and then those 3 regular size pieces. So this is what's happening with fractions. These are different, you know, parts of a whole. So we have to make them all the same. So that would be like taking a pizza cutter then and cutting the little tiny pizza, the large slices into little baby personal pan slices. Then you could say, oh, we've got 2 1/4 personal pan slices or pizzas. All right. So now look, what goes into 2? What does 2 go into that 5 also goes into? That would be 10. So that is the common denominator. Now you go back up and you say, I multiply the bottom by 2 to make it be 10. So I multiply the top by 2 to make it be 10. Essentially, I'm multiplying the fraction by 1. Think about that. When I multiply any number by 1, I get the same number back out. So if I take 17 times 1, it's 17. That's essentially what's happening here. I'm just multiplying by a fancy one. So negative 1/5 is equal to negative 2/10. These are exactly the same fraction. All right, this one, multiply the bottom by 5, multiply the top by 5, so that's negative 5/10. So I have negative 5/10 plus negative 2/10. Be careful, we do not add the denominator. That stays common, 10, because that's like how many divisions you have of the original whole. And then negative 5 plus negative 2 is negative 7. Negative 7/10. Now, had I not used the lowest common denominator, what if I would have looked at 2 and 5 and said, oh, they both go into 20? I could have used 20. It will work. You can use any common denominator. It doesn't have to be the lowest, but then you'd have to reduce your answer for sure. Now, sometimes even when you use the lowest common denominator, you still have to reduce. So what does 6 go into that 10 also goes into? Yes, they'll both go into 60, but there's a smaller one, 30. And so the lowest common denominator. Now, there's another way to do it. You could break down 6 into 2 times 3, break down 10 into 2 times 5. And when you're looking for the LCD, you take what they have in common, and then you take all the leftovers. So 6 times 5 is 30. So that's a different way of getting it if you can't just look at it and figure it out. All right. Even if you use 60, though, it'll still work. You'll just have to reduce it at the end for sure. Times 5, that's negative 5, times 3, that's 3. So look, even though I use the lowest common denominator, I'm still going to have to reduce this one anyway. That's lowest terms. You see 2 goes into 30 and 2 goes into 5. And so negative 1/15. All right. Let's look at 26 and 28 and 31. So 26. So I think we're just going to do to 1, 3 here. 1, 1 to 1, 3. All right, so 26, negative 10. What do you add to negative 10 to make it go away? What do you add to 17 to make it go away? What do you add to 3/4 to make it go away? What do you add to negative 6.5 to make it go away? So those are additive inverses, meaning what would I have to add to that number to make it poof, turn to 0? And then here I want to do 28 also for minus 10. Oh, they want me to rewrite these ones. Yeah. I can do a rewrite on those. And then 31 I wanted to do also. 11/16 minus negative 3/16 and negative 5/6 minus negative 3/4. So, a fraction. We're gonna have to do a bunch of stuff to that. Okay, so here. First of all, what are the inverses? Well, what's the opposite, basically, of negative 10? That's positive 10, negative 17, negative 3/4, and positive 6.5. If you add those together, you get 0. That's all in additive inverses. Here, they basically, you might have had a teacher at some point make you write them as addition problems, like 4 minus 10, they wouldn't let you write that. They made you write 4 plus negative 10. The reason that they did that was likely because so many students make the mistake when they see 4 minus 10, their brain yells 6, 6, 6, because you're just used to 6, 10 minus 4. If you rewrite it as an addition of a negative, first of all, plus, negative, and minus are synonyms mathematically. They mean the exact same thing. I don't usually make my students write them. You get to use your calculators. You can run it through your calculator if you tend to mess these up. But the reason that somebody might have made you rewrite it like that was so that it basically draws focus to the fact that it's a negative number, a positive number being combined with a negative number. And then your brain hopefully doesn't trick you out of the right answer. This one, I would rewrite anyway. Whenever there's 2 negatives in a row, that's a positive. Think about that. If you subtract debt, that's the same as giving somebody money. If your kid owes you 20 bucks, and then you get home and you say, forget about the 20 bucks. They're up 20 bucks, They spent the 20 at the fair, and you said, you got to pay me back. But when you got home, you forgave the debt. Well, they're basically up 20 bucks. When you minus a negative, that's the same positive. And so let's see, negative 1 plus 6 is 5, and negative 9 plus 3 is negative 6. All right, here we'd have to rewrite that to 11/16 plus 3/16. That would be 14/16, but then I could reduce it, divide by 2, top and bottom, and that's 7/8. And this one, I have to find a common denominator between 6 and 4. That's 12. And I have to make that into a plus. So I'm doing 2 things at once there. This, I multiplied the bottom by 2, the top by 2. I got negative 10. This, I multiplied the bottom by 3, the top by 3. Now remember, it was minus a negative, so it's already a plus. So it's positive 9. So negative 10 plus 9 is negative 1. 12. All right. So that's 1.1 to 1.3.